Ever landed on a web page where things just looked, well, wrong? Maybe the text was all jumbled, or things were overlapping, making it impossible to actually get the info.
Yeah, that's definitely a frustrating moment. Happens all the time.
It really does. So today on the deep dive, we're going to explore what actually goes on behind the scenes when something like that breaks.
That's right. We're digging into a real-world example. There was this website hosting programming tutorial videos,
Okay.
And they also had the source code for the projects right there. Well, they ran into a bit of a snag.
Ah, okay.
And we'll look at how they identified the problem and fixed it, specifically an issue where users couldn't properly see the code.
Right.
Think of it like getting a backstage pass to how software problems get solved.
And this is useful for really everyone, isn't it? Even if you've never written any code.
Absolutely.
Because it gives you a sense of the kind of complex stuff happening just to keep the digital world running smoothly.
Yeah, it's a glimpse into that problem-solving process.
It's a bit like understanding how a magic trick works.
Yeah.
Once you see the steps, you appreciate the skill,
A good analogy. And our guide for this deep dive is actually an excerpt from a document. It's called Introduction to Fixing Issues.txt.
Okay.
And it basically lays out the fundamental steps for investigating and sorting out application problems. It's written to be pretty understandable, even if you're new to all this.
Got it. So our mission today is to follow the whole life cycle of one of these user-reported problems. From the moment someone spots it, right through the diagnosis, the fix, and then making sure it doesn't happen again.
Exactly.
Okay, so this whole process kicks off when a user actually finds something wrong. Tell us about that initial report.
Right. So the specific problem reported was on the source code page of this tutorial site.
Yeah.
Users were saying that instead of seeing the raw HTML code for the web projects, the actual p tags and div tags and stuff.
The building blocks.
Exactly, the building blocks. Instead of seeing that, the browser was actually interpreting it, rendering it as part of the web page itself.
Oh, wow. Okay.
So imagine trying to learn, say, Spanish, but instead of seeing the Spanish words, you just see the English translation. It completely defeats the purpose.
Yeah, totally. It's like trying to read a recipe where the ingredient list is being, cooked along with the instructions. Useless.
Precisely.
So the dev team gets this report. What's their very first move? What do they do?
Well, typically the first crucial step is trying to recreate the problem themselves.
Okay.
They'll set up a controlled environment, like a test server, and see if they can make the error happen there.
Right, so they can actually observe it without affecting the live website everyone's using.
Exactly. And it helps them figure out if it's a widespread issue or maybe something weird with just one person's browser or setup,
That makes a lot of sense. You wouldn't want to start tinkering with the main site based on one report if it turns out to be like a one-off glitch.
Precisely. And this first step, trying to replicate it, also helps them figure out if it's maybe a problem they've seen before.
Like a known bug.
Yeah, maybe something with a known quick fix or a workaround already documented somewhere. Or is it something totally new that's going to need a proper detailed investigation?
Okay.
And fundamentally, early on, they're trying to answer, is this a data problem or is it a code problem?
Data versus code. Can you clarify that a bit?
Sure. So a data problem might be, for example, if the links pointing to the source code files were just wrong in their database. The code displaying the page might be fine, but the information it's trying to show is incorrect.
Got it.
A code problem, on the other hand, means the software itself, the instructions making the page, has a flaw.
And in this specific case with the HTML showing up wrong.
It turned out to be a code issue. Something about how the system was handling HTML that was embedded within the source code it was trying to display.
Okay, so they've narrowed it down. It's in the code. Where do they look next? How do they find the actual culprit?
Well, the source material says the developers managed to pinpoint the issue pretty quickly to a specific, relatively small piece of code, often called a function.
Right, a function.
And this particular function was the one responsible for actually generating those HTML pages that display the source code.
Okay, so its whole job is to make that page.
Exactly. And here's the interesting part. The function, whose only job was to output HTML for the page structure, itself contains some embedded HTML tags related to the source code it was displaying.
Whoa, wait. So the code making the page had code in it that wasn't supposed to be run, just displayed.
Kind of, yeah. It wasn't being treated as plain text to be shown to the user. It was being interpreted by the browser as instructions.
It's like a blueprint for a house accidentally having instructions inside it on how to draw blueprints, messing up the main plan.
That's a really good way to put it. Yes. So it's this one specific component, this function, causing the display issue.
I imagine that's where, like, being familiar with your own code really helps, or having good notes if someone else wrote it.
Absolutely. The source points this out. Ideally, a developer knows their software inside and out.
Or relies on good documentation.
Exactly. If it's someone else's code, good documentation is like having a map. In this case, they said once they knew where to look, the problem was, and I quote, fairly obvious to a programmer.
Okay, so they found the smoking gun, this faulty function. What's the actual fix involved?
So the core fix is about changing that specific bit of code.
Right.
They need to modify it to make sure that any of those embedded HTML tags, the ones from the source code being displayed, are explicitly treated as plain text.
So they just show up as PR div instead of actually making a paragraph or a division on the page.
It's exactly right. They need to be escaped is the technical term usually.
Wow.
So the browser just displays them literally.
And that ensures any new source code pages generated after the fix will look correct.
Correct. From that point forward, it should work as intended.
But here's where it gets maybe a bit more complicated, right?
Mm-hmm.
What about all those pages that were generated before they fixed the code? They'd still be broken, wouldn't they?
Exactly. And that brings up a really crucial point in fixing software bugs.
Right.
You have to assess the scope of the data problem caused by the code bug.
You mean?
Meaning, how widespread was the damage? How many existing source code pages were generated incorrectly by that faulty function before we fixed it? Because fixing the code stops the problem going forward, but you might have this backlog of incorrect data, in this case, incorrectly generated HTML pages.
And fixing that could be a whole separate job.
It absolutely could. The effort to go back and regenerate or update all those affected pages might actually be, more work, potentially significantly more, than fixing the original code bug itself.
Wow, so it's not just patching the leak. Sometimes you have to clean up the whole water damage afterwards.
That's a perfect analogy for it. You have to figure out, was it just a small drip or did it flood the whole basement? That assessment is really key to planning the full fix.
Okay, so let's say they've fixed the code and they've dealt with the backlog of bad data, the incorrectly generated pages. What's next? How do they stop this kind of thing from happening again?
Yeah, prevention is huge. The source material really emphasizes communication within the development team.
Sharing the knowledge.
Right. Telling everyone, hey, we found this issue. Here's what caused it. Here's how we fixed it. It becomes a learning opportunity for the whole team.
Makes sense.
And it prompts the question, could our testing procedures have caught this earlier?
Right. Could we have prevented this from ever reaching the users?
Exactly. And that naturally leads into looking at their testing processes, particularly something called regression testing.
Regression testing. Why is that so important after a fix like this?
Well, regression testing is absolutely essential because whenever you change code, even fix a problem, there's always a risk you might accidentally break something else.
The law of unintended consequences.
Pretty much. Or you might even reintroduce an old bug that you thought you'd fixed ages ago. That's a regression. So regression testing involves rerunning a whole suite of tests, covering areas of the software that weren't directly touched by your recent fix, just to make sure everything else still works correctly.
So it's like you fix the leaky faucet, but regression testing checks that fixing it didn't somehow, break the dishwasher or make the shower start leaking.
That's exactly it. In this specific case, they'd need to verify that fixing the HTML display didn't suddenly break, say, the video player on the site, or the user login, or something else unrelated.
That makes perfect sense. It's like a full system health check after the operation.
Precisely.
So after the code is fixed, the old data is corrected, and all these tests, including regression tests, come back clean. Everything looks good. What's the final step?
Only then, after all the testing passes, is it considered safe to deploy the updated application, the fix, to the production environment.
That's the live website that users actually interact with.
Correct. And that deployment itself needs to be managed carefully, often done during off-peak hours, maybe with monitoring, just to ensure a smooth transition for the end users.
Okay, wow. So just to recap the whole journey then, the user reports an issue. The developers try to replicate it in a safe test space.
Yep.
They figure out if it's a data problem or a code problem, in this case, code.
All right.
They hunt down the specific bit of faulty code, that function.
Find the source.
They implement the code fix.
Patch it up.
Then they deal with any existing data that got messed up before the fix.
Clean up the consequences.
Then they test everything thoroughly, especially checking that the fix didn't break anything else that's regression testing.
Super important step.
And only then, finally, do they release the corrected version out into the wild for users.
That's the process in a nutshell. It's methodical, step by step, from symptom to cure and prevention.
So the real key takeaway here seems to be that fixing software isn't just some quick magic wand wave.
Definitely not.
It's a very systematic process. It involves investigation, careful problem solving, cleaning up, and putting measures in place to prevent repeats.
Yeah.
It really does sound like digital detective work.
It often feels that way, yeah.
Yeah.
And hopefully for you, the listener, the next time you encounter some weird little glitch online, you'll have a bit more appreciation for the often invisible work that goes into diagnosing and fixing it. It really shows how complex the software we rely on is.
And the effort people put in to keep it running.
Absolutely. The dedication involved in maintaining it all.
It truly makes you appreciate those intricate hidden processes behind the tech we just kind of take for granted every day. And maybe think that every bug, while annoying at the time, is actually an opportunity. An opportunity to learn, to improve things, and make the digital world just a little bit more solid.
Well said. It's a continuous cycle of improvement.
Which makes you wonder, doesn't it? What other complex, unseen processes are constantly humming away beneath the surface of the technologies we use without a second thought? Definitely something to ponder.
It's definitely something to think about.
Thanks for joining us for this deep dive.
It was a pleasure.